All right, this is a special motion and rates of change part 2. It's a little bit of a harder question. It's getting us to think a little bit more. We've got a rectangle, has 2 vertices on the x-axis, and 2 of the curve y equals e to the negative x squared. We want to find the x value for the rectangle has a maximum area. First thing I need to do is find the area of this rectangle. The area of a rectangle is a base times the height. The base here is RQ. Now, it may be difficult to realize what is RQ, but this x coordinate of P is x, which means that length there is x. Now, because this curve, you can see it is symmetrical, that point over there would be negative x. So that total length there is going, or the base is going to be 2x. So it works really nicely. The height is going to be the point, the y coordinate where that x is. And you can see from that point there, it's e to the negative x squared. That's going to be that length there. So it's 2x times e to the negative x squared. It's really not too bad here. So I want to find the value for x of which it's a maximum area. How do I find maximum area? Got to find that first derivative. And this right here is product rule. U is going to be 2x. U dash will be 2. V will be e to the negative x squared, my god. V dash will be negative 2x e to the negative x squared. Differentiate the power. Power comes out the front and the power remains the same. We differentiate it, bring that derivative out the front, power remains the same. VU dash plus UV dash, the first derivative there. V U dash, 2e to the negative x squared plus UV dash minus 4x squared e to the negative x squared. That's the first derivative. Want to find its maximum area. Want to find when that first derivative is equal to 0. Now, because I've actually got the graph here, we can see there, it's going to be a maximum there. We can see that there is a maximum around that point, so I don't actually need to prove it. I can just find out what that value is going to be. So I've got 2e to the negative x squared minus 4x VU dash U, minus 4x squared e to the negative x squared is equal to 0. Let's factor out e to the negative x squared. I've got 2 e to the x squared, take it out. I've got 1 minus 2x squared is going to be equal to 0. Let's solve this. 1 minus 2x squared is equal to 0. I know this, I've written x, no, it's okay, x is good. Add 2x squared to both sides. Divide by 2, over 2, sorry, and we're going to square root both sides, which is 1 over root 2. So that's going to, and it's plus or minus as well. It's going to be on either side, but because we're dealing with a rectangle and because we're dealing with length, it's going to be positive, greater than 0, as we are dealing with length in this particular scenario. And so we can see that it is indeed a maximum there. And to find B, the maximum area, we would simply just sub x equals 1 over root 2 into the equation for the area, which is 2x e to the negative x squared. So it'd be 1 over root 2 e to the negative 1 over root 2 squared. Press some buttons, I get 0.86 units squared. So, and that's really going to be it. So it's getting you to think about things a little bit more. If we needed to, we could show it's a maximum by finding the second derivative, by using another product rule or factoring out. It's going to be a punish. We don't really want to do that. We don't need to because we've got the graph. It really helps us. And that's a little bit of extension on rates of change.